Welcome to our business track. This video will be the most helpful for data professionals to build efficient models and ensure that their recommendations for modeling efforts are as accurate as possible. Tubis, Senior Director of Retention Analysis at Disney Streaming Services, is going to introduce a framework that will follow and discuss a modeling approach and critical junctions in the modeling process to ensure that models are less biased and higher performant. She discusses how to add the human element in hiring and modeling to create diversity and representation in your business. Check it out.
Hi everyone, welcome. We are going to talk about how adding the human element from hiring to modeling and having representation in data can have a positive impact on modeling performance. My name is Tubis, and I've led data and analytics teams at large and small media and tech companies, currently working at Disney Streaming Services and leading the Customer and Churn Insights team under Customer Modeling, where we really focus on who our Disney Plus, ESPN Plus, and bundle with Hulu subscribers are, why they take the decisions that they take, and how we can ultimately give our subscribers the best user experience. Here, we have a very wise statement. Your data set must be very large, diverse, and indistinguishable from the reality you seek to model. And so we know we need to have representation in our data to improve performance. But I ask the question of, are the modelers also representative of the audiences? Why don't we have representation, and does that matter? I went out searching for examples of how having representation might have a positive impact on performance. And I found a bunch of negative examples of how not having representation has a pretty impactful and could have some pretty dire consequences to human beings. The Weapons of Math Destruction by Cathy O'Neil has some great examples there. I also found studies showing how the positive impact of how having diversity within an organization ultimately improves business performance overall. But I came up short in finding studies showing the positive impact of diversity on modeling results. And so I invite you today to go on a journey with me to prove that having a diverse team is likely to have a positive impact on modeling results. But first, let's talk about my run-in with an algorithm. Welcome, a dating app. I was divorced, single mother, and I was ready to get back out there. And so I decided to go on a dating app. And this app asked me all kinds of questions about who I am, how I live, whether I brush my teeth every day, and whether that's something that's important for me to have in my future partner. They ran after I completed the questionnaire, an algorithm was run, and I got my supposed perfect matches that I could meet. But what I realized were a lot of critical questions were left out, in my perspective, for me to find that perfect partner. And what I also realized was, when I finally had met my perfect partners, that I would never have met them if I had followed the recommendations of the algorithms. So asking the right questions and feeding the algorithms the right data is critical. Now, who comes up with these questions? The data scientists oftentimes do, right? The human beings. And so imagine you have two data science teams. On the left-hand side here, you see a data science team that is representative of a global media company in terms of race, age, gender, as well as background, languages spoken, and experiences had. And on the right-hand side, you see a homogeneous group of white men. And so I ask you, which do you think will provide a more representative set of questions and data to an algorithm? When I was building a global data team at a global media company, I was hiring for multiple data scientists, and I had many of the candidates that came my way were white men from America, educated in top-tier programs, PhDs, and one non-traditional candidate had applied, was a VP of in business development in her past life, was not from America, had no data science experience, but did go through a pretty intensive data science bootcamp program, and way back when did actually get her education in math, and so technically she had a great mathematical mind. Now, this candidate was representative of our subscriber base and took a blind data challenge. And lo and behold, she performed best on this data challenge in terms of critical thinking, asking the right questions from the data, and coming up with really interesting solutions. And so she ended up getting hired, and she brought a different perspective to the team, asked great questions, was able to come up with the right objectives to optimize for, diversified the data that we used, and also came up with interesting perspectives on how to interpret the data. So what I learned from that experience was getting the right representation was critical for us to get stronger performance. Now, in any modeling effort, there are, and I'm simplifying this, there are like generally 4 steps that you take. 1, you want to define your objective function, then you want to gather all of the data and want to probably understand that data, feed those inputs into an algorithm or algorithms, and then ultimately get some sort of output, whether it's black box or more interpretable, but you can come up with some sort of representation, interpretation, productionalize it, and then act on that data, hopefully in some way or another. But what is really critical before that first step is taken by any data science team, and I find that this step is often missed, is identifying the overall goal of why we're doing what we're doing. And so oftentimes what I find is that the data science teams are thinking through that goal, but it's really important to discuss that goal with the business leaders, with the stakeholders, to really understand, like, what should our objective function really be? How will the result actually be used by the business? And so here, the human element is critical and unfortunately sometimes overlooked. Let's take an example. Imagine we have a media company. This media company relies on advertising revenue. So people read their content, they see ads, the media company makes money. And before kicking off this big project to make more revenue, which was identified as a goal for this company, the business team basically tells 2 sets of data scientists. Here we have a data science team on the left, Dabber 1, data science team on the right, Dabber 2. These 2 data science teams are dabbing for my 12-year-old daughter because they're so excited about all the work that they do. And they tell these data science teams that ultimately they want to add in recommendation systems within their content to get people to click into more content, see more ads, and make more money. They decide we don't want to show our readers more ads within the content that they're viewing, but we want to get them to read more. And what these business teams tell these data science teams as well is that there are 2 metrics that drive advertising revenue, and that's click-through rate. So as people click, they see an ad, media company makes money, and time spent. As people click, they see an ad, and as they scroll, they see more and more ads. But the rate at which the ads show up slow down because we don't want to give a really terrible experience, or the media company doesn't want to give a really terrible experience. And so this media company clearly identified this goal of making more money to these two data science teams, but one data science team, represented by Dabber A, is not representative of the reader base and actually doesn't even read the content. And then Dabber B represents a data science team that is representative, that reads the content. Now, when they get to that first step of defining the objective function, knowing the goal, Dabber A will say, okay, well, there is a very strong relationship between click-through rate and ad revenue, so we should absolutely be optimizing for click-through rate, which makes sense. But Dabber B might say, well, let's look at our top content based on click-through rate, and they find that it's a little fluffy and could even be considered as clickbait, and might not even be, might be just as bad as showing another ad. While if Dabber B looks at the content, the top content by time spent, they might find niche pockets of different types of content that are read by different types of audiences. And so Dabber B might decide to optimize for time spent. And so what I posit is that the recommendation ultimately, once we get through all of these steps and the modeling results ultimately get productionalized from these two data science teams, the result from Dabber A will likely be very catchy headlines that people are more likely to click through, but maybe it might turn them off because the content just won't be there. And Dabber B might actually get less people to click, but more to scroll and potentially become these super fans, then come back because they're getting the recommendations that they really want. Let's look at step 2, gathering data and understanding it. Dabber A, as a reminder, who's not representative, might say, let's throw all the data that we have into our model and see what happens. While Dabber B might say, well, hey, there might be certain things we need to really understand and account for and adjust for. There might be some feature engineering we want to do by really understanding the subscriber base and their actions. And one person on Dabber B's team might say, you know, in this low-income neighborhood that I grew up in, I was only able to read content that that I wasn't able to read all the content because load times were really high because of the really poor connection that I had. And so they might decide to bring in load times into the algorithm and zip codes and location-based information that might not be readily available in Dabber A's data set. And so having a more holistic view of the subscriber and bringing in some additional data points that might not be necessarily apparent towards improving modeling performance will likely improve model performance, or at least we'll see. And so here I show this full process represented in a different way. We're setting the goal, defining the objective, and identifying the right inputs are really critical in any modeling effort, as you all know, and they rely so much on the human element. As Payal Jain, who is the chair of Women in Data, puts it, you've got to have diverse teams to even spot bias in the first place. She says, and I quote, there are 3 things that are really important when we start thinking about AI and machine learning. It's not so much about data, it's about the people. Firstly, we've got to be aware of our own biases. Secondly, we need diverse teams to work with technology. With 78% of people working in AI being male, there are biases that they naturally won't spot. Finally, we've got to make sure we're giving the machine non-biased data sets. We all know this, but I think it's really important for us to really internalize this. Machines are only as smart and biased as we make them. So what's key in performance improvements, in my perspective, is the people, the engineers of the algorithms, and the ones who feed the algorithms data. Now, do we have representation today? Not according to a recent study done by Genpact, where they surveyed over 500 executives globally across many different industries that are actually much more advanced than media and entertainment, although media and entertainment companies were not a part of this survey. The companies include like financial services, healthcare, tech companies, and they found that 66% of companies have not optimized for AI bias. That is a really surprising statistic in my perspective, considering where we are today and the potential negative impacts that AI bias could have. And so before jumping into any data science project, it is really important to ask yourself, do you have the right people? From hiring practices to also training and creating the right culture and environment to support diverse perspectives and better performance. Let's start with hiring practices. So one thing I do that has proved so helpful in all of my hiring efforts has been to request from the recruiter that I get representation in my candidate pool, because if 99% of the candidates I get are white men, I am much more likely to hire a white man. It's just statistics, right? And so once you have representation in your candidate pool, do a blind screening. Give a technical challenge that really tests strategic thinking from diverse perspectives. And I'm totally happy to answer any questions afterwards on the types of technical challenges that have worked for me. And then make sure that not only are you thinking about diversity when you're hiring, but also when you're interviewing. So make sure you have a diverse cross-functional panel. Then comes training. So what I like to do is to involve my entire team in the onboarding process, which ultimately leads to having a better culture and creating a more inclusive environment. I also like to throw in new hires into projects to help them learn by doing and have the team really help support them there. And then finally, creating an inclusive environment and safe space where you give your team opportunities to ask questions, to try new things in a responsible way, and encourage diversity of thought through that gets to stronger solutions, stronger team dynamics, and stronger relation to the ultimate diverse audience that you have. And so here we are. At the top of this rainbow that we just went through together, we have a crucial step in all modeling efforts, establishing the goal and defining the objective function. But based on my experience, the rainbow starts way before that, and that's in hiring the right people that are representative of the subscriber base and creating the right culture for them to be able to get to that right objective function and to gather the right data and get to the results that you're looking for. Remember, machines are only as smart and biased as we make them, and what's key in performance improvements, in my perspective, is the people. Kathy O'Neill, that author who I mentioned of The Weapons of Mass Destruction, tells us, and I quote, "Big data processes codify the past. They do not invent the future. Doing that requires moral imagination. And that's something only humans can provide. We have to explicitly embed better values into our algorithms, creating big data models that follow our ethical lead. And I firmly believe that the way forward in data science is through moral imagination."
That was a presentation by Tubis, Senior Director of Retention Analytics at Disney Streaming Services, who provided insights into adding human elements into hiring and model processes. If you found this video useful, make sure to subscribe to our channel and find more presentations like this below.